We can begin.
And okay, great, no problem. Not just the light a little bit here.
So, yes, good evening, everyone. We welcome Senior Project Controls Manager of Jacobs Engineering Group, Martin Lopez, as a speaker to the third edition of Project Controls Expo Virtual 2022. In this presentation, Martin will be talking about schedule delay analysis for project managers. Questions will be addressed at the end of the presentation. Over to you, Martin.
Yes, thank you very much to everyone. It is 7 a.m. in Panama City, and I'm going to start the presentation, which I prepared for you guys today. A little bit of an introduction for me. My name is Martin Lopez. I have 34 years experience working on many different roles in several types of projects in different places. This is, for example, some of the projects and locations I worked. Panama City, I am here today, been here for the last 10 years. Most of my career has been in the United States, and I also have a few projects in the United Arab Emirates. Now, this presentation is prepared for those of you who are not experts in the delay analysis, but who are in projects and have or may run into issues of delay in the future on your specific projects. And not being an expert in delay, you may have heard or been through delays, and this presentation is going to help you to follow the delay analysis process, being the preparation of documents to prepare a delay claim or defend against a delay claim. And this way, then you can follow with attorneys if they ask you for documentation, or experts who may also ask you for documentation. And in the presentation, there are exercises that I prepare with monthly updates, and I inserted a few delays. And we are going to go through the exercises, and you're going to be able to understand the different categories of delays and how to assess and how to deal with and categorize delays. But first, I'm going to go through a few definitions that are very important in delay analysis. Now, some of these definitions may be very familiar to you, and you know exactly what they are. But nevertheless, they are quite important in delays claims. For example, extra work. We know what it is. I mean, it is you know what the contract is, and the documents specify what is the contract that is required. And it should be very clear what is extra work and what is not extra work. So this is a very simple definition, but yet it is one of the main causes of claims. You may say it's extra work, and the counterpart says it's not. And then a dispute arises on a very simple definition, which may not be very simple to establish. So that's extra work. Then we also have direct cost and indirect cost. And this is important because in delay claims, when a delay is compensated, you compensate indirect cost. While direct cost, you typically compensate through a variation order or a change order. Direct costs are more related to physical works, to the physical resources or expenses to place concrete to excavate, for example. Indirect costs are those items that are, for example, insurances, startup of the project, and other costs, your engineers, your offices, and expenses that are related to time, not necessarily to place work in the field. We have more definitions. An as-built schedule, for example, versus a baseline or a monthly update. Most of you know what an as-built schedule is, but it is important to have a good as-built schedule with good actual dates, start dates and finish dates. Because when you come to the end of the project and you need the as-built schedule to assess a delay, you have something you can rely on as far as when things were completed. And you can also follow the sequence of how things were completed. There are also recovery schedules that are typically performed during the project execution. And these recovery schedules are not acceleration schedules or are not typically contentious. These are typically schedules that are prepared to recover lost time without claiming or blaming any of the parties in the project. We also have liquidated damages, which is an amount that is charged to the contractor, and it's typically by day, by the number of days of delay. When the contractor, for example, is responsible for a delay, then there's typically a stipulation on amount of fees that are paid, that are charged to the contractor for finishing late. For example, a contract may stipulate damages of $200 per day on a specific contract. And if there is a 20-day delay attributed to the contractor, then the liquidated damages on this specific example will be $4,000. And we'll have an exercise that explains this in more detail. Now we have acceleration of the project. We have directed acceleration and constructive acceleration. And I'll give you an example of directed acceleration on a project in which I was involved. This had to do with a bridge reconstruction, removal and replacement of a railroad track. This particular bridge was across a channel that connected the Navy operation to the ocean. And the Navy had a requirement that this particular access had to be open at specific times out of the year, 6 months out of the year. So when the project started, some delays started to accumulate as the contractor was not able to remove the bridge in time so that the access would be open. The owner decided to direct the contractor to accelerate. And the contractor added more resources, added more subcontractors, and was able to remove the bridge and have access to the ocean so the Navy can go through. So that's an example of directed acceleration. Now, we also have what is called constructive acceleration, which is a different situation. In a constructive acceleration situation, what happens is typically a contractor is entitled to a time extension through issues of delay, but the owner declines to grant a time extension. and the contractor feels that they are in trouble, and then the contractor accelerates the project so that they can finish on time. And then if later it is revealed that the contractor was correct and that the contractor was entitled to a time extension, then the contractor is able to claim the costs of accelerating the project. And this is what is called constructive acceleration. And it is used in construction claims. Now, types of delay analysis that are typically used, one is called prospective analysis, the other one is called retrospective analysis. And they have different uses, and they are good for specific reasons. For example, a prospective analysis is done during the time that you're at the job site and before or during a delay event, and it's contemporaneous with the time. This prospective analysis method, what it does is provides an estimate of delay because the delay has not been completed or the event has not been completed. So typically there is an estimate of how much it would take to complete the extra work or the issue that is delaying the project. And this uses the current update at the time that you're working on. Now, it has a disadvantage that you are estimating the project, and you may estimate not enough or too much time. So there is a downside for that. Retrospective analysis is done when the delay has already occurred and the number of days of delay are known. Sometimes when there is no agreement as far as what a delay is or should be, then the delay continues, the delay event is completed, and then the dispute arises, and in this case, a retrospective analysis is performed. It is just an example of prospective analysis. You're looking forward, you're looking into the future, you're estimating the time that it would take to arrive at your goal. A retrospective analysis, you already know the distance, you already know the time, you already know the details of the event. These are differences in methods. Now, as far as the types of claims for delays, there are excusable and non-excusable. Then within excusable delays, we have compensable delays, and you have non-compensable delays. Now, non-excusable delays are typically non-compensable. So an excusable delay is when the contractor is entitled to a time extension. And an excusable delay provides relief to liquidated damages and is compensated, typically compensated. Non-excusable delay is when there's no justification for a project delay and the contractor is held responsible for such a delay. Now we also have a concurrent delay and a compensable delay. Concurrent delay is when two events are delaying the project at the same time, but more so when both parties are responsible at the same time for delays during the same period. And so these delays are happening concurrently at the same time. In this case, these delays are not compensable, but are excusable for time, meaning that there is a time extension to the project, but there is no monetary compensation in such a case. Compensable delay, on the other hand, there is monetary compensation for delay. For example, when an owner delays a project for whatever reason, then the contractor is entitled to receive compensation for the number of days of delay. This is a graphic that shows a simple schedule, and it shows a time period of delay that is caused by the owner. And in this case, because that's the only delay in the project and it has been determined is by the owner, then this becomes a compensable delay, owner caused delay. In this other slide, we have two delays at the same time. One by the owner and the other one by the contractor. These are happening at the same time during the same period, so therefore they cancel each other. Now in this case, there's no compensation, monetary compensation to the contractor, or also there are no liquidated damages assessed to the contractor. But however, there is a time extension to the project. Now, compensable delay applies when the owner is responsible, when the contractor is not responsible, when there are no concurrent delays to be assessed, and there is a time extension granted, meaning a delay that has a number of days associated with it. Now, for example, if the contractor daily indirect cost is $300 per day and the delay is 20 days, then the contractor is entitled to receive $600,000 for this particular delay. Now, for a prospective delay analysis or a delay analysis that happens in real time is also called time impact analysis or contemporaneous analysis. And it's typically performed before the delay or near the start of the delay event. And it's usually for extra work or disputed work. This particular method of delay analysis is quicker to produce, quicker to prepare, and it gives you real-time or quick responses so that you can make quick decisions. One disadvantage is that in doing so, you may grant too much time or grant not enough time for particular delay. If you have a complex schedule, a big schedule with thousands of activities and a complicated network, then it can be less accurate because of the many logic relationships that there are in the schedule. This is, for example, a graphic of what a prospective delay analysis or a time impact analysis looks like. Where you see the data date, the blue line is the status of the project, and a delay is foreseen. A delay can be seen that is up ahead, and as represented in the graphic, it's shown with a bar and it's estimated. The time is estimated. And so then if it's, for example, a proposal by the contractor or a wish by the owner, an analysis can be done ahead of time, ahead of the project, ahead of the activity, and then a decision can be made whether to proceed or not to proceed with extra work, for example. So this is a big advantage of this type of analysis. In a retrospective analysis, the delay event has already occurred. There's no argument as to how long it took to finish or to complete or the issue that caused the delay. Gives you for large, complicated schedules. And it's more accurate for long delays. And prepare documents review to baseline for the project. Then from here on, this baseline is updated on a monthly basis. So on our first update, encounter a delay, 21 days, right at the beginning of the project. Then becomes update number 2. time extension of 14 days, but there is no monetary compensation. And then there's also 7 days that are non-excusable, and there are liquidated damages to the contractor. And our project duration is 169 days. And that's in month number 3. Then month number 4, we finish the project and we end up with an as-built. The last update can also be used as the as-built of the project. Now, there are many types of as-builts that can be done. More detailed as-builts are typically done if there are issues that require more analysis on specific activities that are not shown in the schedule. Then you may add a series or a number of activities to the schedule, or prepare an entirely new schedule as the as-built. And so we arrive at the end of the project. And at the end of the project, what we have is a project duration of 169 days. We have 7 days on non-excusable delays that are attributable to the contractor, and liquidated damages then are assessed. We have an excusable non-compensable delay of 14 days, which means there is a time extension of 14 days, but there is no compensation. We have an excusable delay of 21 days, which means a time extension of 21 days and compensation to the contractor. And then let's say we arrive at the end of the project, but during the process of execution of the project, let's say nobody agreed to anything. Nobody accepted any of the analysis that was done. And we come to the end of the project and have no delays resolved. Then what typically is done, you prepare a retrospective analysis, which in many cases you take the baseline schedule and then you compare that to the as-built schedule. And in this case, you identify the delays in the project. And it is time-consuming because there are many documents that now you're searching. Typically, you search for meeting minutes, you search for data reports, payment applications, monthly updates, emails, drawings, RFIs, and any documentation that can assist to tell the story of what happened on particular delays. And in that case, in this way, you can also determine who's responsible for delays. In this case, we have 3 delays in the project. And these are the same delays that we saw earlier in exercise while we were updating the schedule. So we got a delay 1 of 21 days, delay 2 and delay 3 that are partially concurrent, and for 14 days, and 7 days that are contractor responsible, and you have a total delay as shown here. Of course, this is a oversimplified schedule only meant to represent the steps and the definition of the terminology that is used in delays. You can prepare a summary that explains the days of delay. In this case, our original contract duration was 127 days. We have 21 days of delay that is compensable, in time extension. We have 14 days non-compensable with time extension, 7 days liquidated damages, and actual duration of 169 days. So these are two different ways that you have retrospective analysis and prospective analysis that can be done on a project to determine delays and help you navigate through the project when you have delays. And like I said earlier, this presentation is more geared to people who are involved in projects and are not experts in analysis of delays, but need to understand or want to understand what is the process, some of the terminology that is used for delays. And in reality, I think I am finishing a little bit early. So I think I went to the slides a little quick. But this is my contact information. If you have issues, problems, I provide consulting, I provide training on delay analysis, time extensions, project issues, on schedules, baselines, updates, monthly reports. Currently, I'm supporting attorneys with issues, technical reports, forensic analysis on a delay claim. So with this, I finished the presentation, and if you have any questions, I will take your questions now.
Thank you so much, sir. There are 2 questions in the chat box, if you could access that.
Yes, I see the first one. What is the major difference between excusable delay that are not compensable and non-excusable delay that are not compensable? Okay, so an excusable delay that is compensable needs to be entirely the responsibility of the owner, or the contractor needs to be entirely not responsible. As far as non-excusable delay is when there's no excuse, for example, that there is a delay in the project, and mainly it relates to the contractor being the responsible party and the owner being not liable for such a delay. Then it says, another question, is there any way to forecast the delays on the project before starting the project? Well, as far as forecast, you can run a risk analysis on a project and sort of kind of determine what are your risks for time and issues that you may encounter, and you may not, or you could or may not come up with a number of days, but you can assess where you could face problems that could delay the project. So that's something that can be done, and that is done. And that is through risk analysis. Another question. To show the delay in the actual schedule, do we add the new WBS the same way as you have shown, owner delay? You can, yes, you can show a separate WBS, and the reason I did it this way is to make it simple to see and simple to understand. It's not always the case. Even when you may have a WBS shown this way, it just depends on the layout that you prepare and if you sort by activity code, for example, then you won't see the WBS. But the reason I did it this way is to simplify for the graphics and to show it clearly. But yes, it is a good idea anyway, in my opinion, to have a separate WBS for delays. Then there's another question. Could you say there is no global standard to be used in schedule delay analysis? AACE is a basic and global best practice available, or could you tell others? I would say there are certain standards for delay analysis that is used around the world, and the more basic standards are the ones that are more acceptable. And many standards are used because they have been tested in courts. And so they have been proven by courts. And so yeah, there are standards, and the basic presentation that I provided uses the standards that are used in delay analysis. And it depends on the contract as well. And as far as other methods, depends on the contract. You have to read the contract. You may have clauses in the contract that may limit what you can claim in delays. And so that would change the methodology and the process of assessing a delay. But AAC, of course, it has good standards to use, and I would say that other standards are similar to what AACE uses in their practice. Another question is, could you say there is no global standard to be used in schedule delay analysis? Is that the same question? That's the same.
Yes, it's the same question, yeah.
So we jump into another question. Hurry up now. Is it ethical to accept a dispute analysis when it is notorious the complete lack of schedule and delay causes documents should be refused to deal with and consider it extinct? That's difficult. That is difficult. I mean, you can blame negligence as far as scheduling practice, but if there is an issue when one party is clearly responsible for delays, you are, in my opinion, obligated to do your own analysis and demonstrate to the courts why and who is responsible and for how long. It is, of course, not desirable not to have the documentation that is required, and to defend your claim or to defend your position, it's much better to have a good schedule and good scheduling practices. I know it's not always the case, but it's always better to have good practices. Next question, can you explain an example of prospective and retrospective analysis? Well, basically, prospective is before the end of the project or before the delay. And for example, if the contractor gives you a proposal to improve a certain aspect of the project, and they give you a price and they give you a time, and it tells you it's going to take 21 days as a proposal, that could be considered a prospective delay analysis on something that has not yet occurred. Then you as an owner have an option to accept or not accept the proposal based on the price and based on the time. Retrospective analysis is, for example, when the delay already occurred and you have no option but to proceed with the work and wait until the end of the event, and then determine how long it took and who is responsible. Next question. What can we have your LinkedIn details to follow you? Yes, of course. My LinkedIn details are in the presentation, in my detail in the contact information. You can have it. You can see it there. You can see my email and my LinkedIn information. And I think that's all the questions that we have. I don't, unless there are any other questions. I think you're right on time. We have 3 minutes to spare. A couple other things to mention. Document everything in the meeting minutes. Ask the right questions. Ask questions. Make sure that the responses are written down. Later you will come back and you may need that information. So document. To prove the best defense on a claim is documentation. So document all you can. Another question. You may consider not to answer. Well, this is a suggestion. Is it correct to consider Microsoft project schedules as proof of documentation? Well, not necessarily. You can use Microsoft Project. The disadvantage with reference to Primavera, Oracle Primavera, is the complexity of the project and the capability of the software. But there's nothing wrong with using Microsoft Project as long as Microsoft Project can handle the activities, the WBS, but there's nothing wrong with Microsoft Project schedules. I prefer P6 because it's more robust, and for complex projects, it gives you a better schedule. Anyway, so I think we're past.
I think that was the last question. Thank you so much, Martin, for answering all the questions in depth. And thank you everyone for attending the Networking Cafe, or indeed to visit our partners at the Partner Showcase area. Thank you so much, everyone. Good day.
Good day, everyone. Thank you for attending.